What's up, guys? It's Mr. Brengle, and today we're going to be talking about the work concept builder from physicsclassroom.com. And at this point, you should have already learned about work, but work is defined as a force that's applied to an object over some distance. So the equation is quite literally force times distance. And work can be positive, negative, or if it's not present, zero. So what determines whether it's positive or negative? So positive work will be done when the force acting on an object is acting in the same direction that it's moving. And that will add energy to the object. Okay. And just remember, conservation of energy, we're not creating or destroying energy. It's just transferring, but it's going to transfer energy to the object, which would maybe be a better way to say that. And then negative energy, opposite direction, going to remove energy or transfer energy away from. So something like, experiencing friction to slow down, for instance. Okay, so let's look at some examples here. It says Jonah holds the dog tightly by its leash to prevent it from moving. So Jonah's applying a force here. He's gripping the leash, but it's not applied over some distance. So when you multiply force times distance, it ends up being zero. So therefore, there is zero work done in this situation. The weightlifter lifts the barbell above her head. So in this case, the weightlifter, she pushes up, so she applies a force, and then the barbell moves some distance and therefore gains gravitational potential energy, and therefore positive work is done here. And it says a baseball is brought to a stop upon hitting the catcher's mitt. So the force applied here is the mitt pushing against the ball when it comes in. And it does apply it over some distance. Usually when you catch the ball, you're going to give some here. Now, this is going to be negative work because if you think about it, the baseball has kinetic energy, right? It's moving very fast, and then it goes down to zero kinetic energy when it hits the mitt and it stops. So in this case, energy is being transferred away from the baseball, and therefore negative work is done. Okay, so there's an example of each positive, negative, and no work. We'll go ahead and go back to the main menu here, and we'll move on to the next activity, since you can figure that out. So in this one, we are trying to figure out, basically explain the situation of how work is done on the object. So it says, the students push on the stationary box to accelerate it across the gym floor. So in this situation, work is done on the box by the, and it gives us these options here. The floor pushing upward on the box, no, because it's not moving at some distance vertically. Earth's gravity pulling down toward the box. So these are all things that are true. These are forces that are being applied to the box, but it's not applying it over some distance. However, this one right here, the students applying a force to the box, they're applying a force. They're pushing it over some distance. Therefore, they're doing work on the box. And as a result, the mechanical energy of the box increases. So this is more or less just asking you whether positive or negative work was done on the box. Because the box increases its kinetic energy, its total mechanical energy increases. So mechanical energy is just the kinetic energy plus the potential energy. It's the total energy in the situation. So since the box picks up speed, then it is going to, of course, increase its total mechanical energy. Okay, it says baseball is brought to a stop upon hitting a catcher's mitt. In this situation, work is done on the baseball by the force of the baseball pushing the mitt forward. No, that would be the other way around. It would be doing work on the mitt. The force of the pitcher who threw the baseball initially does work on the baseball, but that's not what this situation is about. The force of the catcher's mitt pushing against the baseball. That sounds good there. That the mitt is what stops the baseball. And the total mechanical energy of the baseball decreases because it initially has kinetic energy. And then when it's brought to a stop, that kinetic energy decreases to zero. So the total mechanical energy, which is kinetic plus potential, is decreasing in that situation. Okay. And then we'll do one more here. It says student lifts books from the floor to the top shelf of a locker. So in this situation, work is done on the book by not the upward force of Earth's gravity on the book, which doesn't exist. The force of the floor pushing up on the student, no. The downward force of the book on the student, no. The upward force applied by the student to the book, yes. So the student applies the force, moves the book. There you go. As a result, the mechanical energy of the book increases because it increases its gravitational potential energy as it's raised up to the top. So therefore, it will be positive work done and total mechanical energy will increase. So I think you guys get the gist there. And we will go ahead and head back to the main menu and look at energy transformation. So this is literally just asking you to indicate the initial energy and what it's transferred into given a situation. So it says starting from rest at the top of the friction-free slide, the child slides to the bottom. So since the child is at the top of a slide, there's gravitational potential energy. As the child slides down the slide, the gravitational potential energy is transferred into kinetic energy. The child's speed is picking up as it goes down the hill. And so that's what we're looking for here is potential energy into kinetic, which happens to be the first answer. I would always go through this and reason with yourself before you start reading answers. Come up with the answer in your head on your own and then look for the answer that you came up with, because they're purposely going to put answers on here that are misconceptions. So if you start just reading through them, there's a good chance that you're going to pick the wrong answer if you see that before the correct one. Along the horizontal section at the bottom of a tall slide, a child slows to a stop. So this is saying like the child went down the slide and then it's on a flat section where the child's just moving horizontally, and then they slow down during that process. So basically just imagine somebody sliding on the ground and then they slow down to a stop. So in this situation, the child initially has kinetic energy because they're moving, so they have a speed, and then that speed decreases because of friction. And so that kinetic energy is transferred away from the child in the form of heat that dissipates into the air. So in this case, it would be kinetic energy into dissipated energy, which an example of that would obviously be heat. Okay, and we'll do one more here, and then I'll let you guys finish it off. The weightlifter lifts the barbell above her head. So in this situation, the weightlifter is using chemical energy that, humans, we have to eat food. So we get chemical energy from the food. There's energy stored in the bonds within the food. We break that down and use it. So chemical energy, and then lifts a barbell above her head. So that's gaining gravitational potential energy. So we're transferring chemical into gravitational potential. And that is what we're going to look for right here. It just says potential energy, but to be specific, gravitational potential. Okay, so that should be enough to get you guys through the concept builder. Make sure that you're kind of reasoning through these situations and thinking about whether there's an energy gain, an energy loss. Obviously, that energy is being transferred. It's not just being created or destroyed. And then what types of energy are involved in the situation. Make sure to let me know if you have any questions.